What up, mathletes? Whoop, whoop. All right, let's do this. This is 11.7, factoring special products. Your learning target is I will factor polynomials by applying special patterns. So do your warm-up real quick. Pause this so that you can work it out, give it a shot. Are these binomials the difference of two squares or not? Ready, set, go. Okay, I'm going to assume you paused this, had some time to check it out. Let's do this. Each has to be a square. 5 is not. There's no perfect square for 5, so that doesn't even matter. Boom, boom. No. Square root of each of these. Square root of 16 is 4. Square root of g squared is g. Minus square root of 36 is 6. Yep. This is. We don't need minus, though. Just yes. This one, or the minus was important because it has to be the difference, right? This one's plus, so it doesn't even matter. No, it has to be a difference. This one's a minus. Square root of x squared is x. Square root of 49 is 7, so yes. So it goes no yes, no yes. There we go. Boom. Probably write it better and don't take up your time. Room for a difference in two squares and perfect square trinomial. But let's go look at our... All right, and here we go. Go ahead and take a minute. Pause this, write these down. The difference in two squares of the two squares, the square of one quantity minus the square of another quantity, and perfect square trinomials are just squares of binomials. So stuff we worked on in the last lesson, but we're going to go at it with a different angle today. So again, pause this, write these down, and we're heading back. Actually, we're going to the next slide. Boom. So we're going to talk about factoring, difference of squares. We did this in our last lesson again, but we went around the opposite side. Now we're going this way. So here's the deal. If I have anything in the form of a squared minus b squared, it's equal to a plus b times a minus b, or a minus b times a plus b. And then examples, look at this. We have x squared minus 9. Well, the square root of x squared is x. Square root of 9 is 3, so this becomes x plus 3 times x minus 3, or vice versa. Same deal here, square root of 4u squared is 2u, square root of 1 is 1. So this becomes 2u plus 1 times 2u minus 1, or vice versa. All right, pause this if you need to. We're going to go back to here. Ready, set, go. Okay, so looking up, check this out. We're going to try this the old-fashioned way, right? So notice I can rewrite this as 121p squared plus 0p minus 36, just so we know what to do with everything. So we would have 121p squared, negative 36 down here, and then 0p right here. And I'll multiply those together, I'm going to get a ridiculous number, which is 4,356. The only way to get 0p is if it's plus or minus the same thing. And believe me, if you take the square root of this, it actually turns out to be 66 then p. Oh, this should have been p squared, by the way. And then negative 66p over here. That's how, and that should have been negative as well. Getting ahead of myself a little bit. All right, so when I put 66p right here and negative 66p up here, what can I pull out of this? Well, I can pull out an 11p. Because this is 11 times 11, and this is 11 times 6. And then down here, 6. Right here, we're going to have another 11p. And then minus 6. So this is 11p plus 6, 11p minus 6. But really, wouldn't it have just been easier to have said, hey, the square root of 121p squared is 11p. And the square root of 36 is 6, and then 11p plus 6, 11p minus 6. That's the nice way you really want to do it. But let's try this. Now we're going to fully factor this bad boy, and that's actually more than you think it is. Watch this. Take the square root of both sides. That's going to end up being x squared, and it is a difference, by the way, and that's going to be 100. So I'm going to end up with, all right, this is equal to x squared plus 100 times x squared minus 100. Believe it or not, we're not done yet, because this x squared plus 100, nothing we can do there. But this x squared minus 100, that's still a difference in squares, isn't it? So that's going to be x, that's going to be 10. So I'm going to be left with x squared plus 100, that stays, right? Times x plus 10 times x minus 10. Now this is fully factored. You got to factor it as much as you can. See if you can take a minute, try this one. That factors quite a bit, but see what you can do. Ready, set, go. All right, I'm assuming you pause this. Let's do this. Square root, square root. Remember, you just half it, so that's going to end up being z to the fourth, and that's 1. So I'm going to have, all right, this is z to the fourth plus 1 times z to the fourth minus 1. Well, guess what? It's still a difference in squares. So we're going to square root. That ends up z to the second and just 1. So I'm going to have z to the fourth plus 1, because there's nothing I can do with the plus 1. But this is going to be z squared plus 1 times z squared minus 1. And you guessed it again, we have one more difference in squares right here, which is that'll be z, that'll still be 1. So now let's finish it off. You ready? Z to the fourth plus 1 times z squared plus 1 times z plus 1, z minus 1. And I always start with a plus so that I can stack them up in case I can keep factoring. Here we go. Boom. All right, pause is needed. Let's go into the back. All right. Sketch a diagram of the crocheted square. Well, if you sketch it, guys, it looks like this. We have this outside of x of this square, and then we have this inside, which is 6 inches. This is x inches, by the way, and by 6 inches. Here's the thing. We want to know, what is this outside area? So think about it for a second. To find that outside area, just the outside area, I need to take the whole area and subtract this middle area, right? Got to subtract this out of the whole area, and then I'll have it. So what is this outside area? It's x times x, right? Because area is length times width, so it's x squared. And then what are we going to subtract? We're going to subtract this middle area, which is 6 times 6, or 36. Now, that looks like a difference in squares. Let's go ahead and write that expression in factored form. Square root, guess what? It's x plus 6 times x minus 6. Isn't that crazy? So now, depending on what x is, we can always find out the area. We can just plug right in. Awesome, and know the length and width and all that good stuff of what it's modeled after. So, again, let's go on to this one right here. We're actually not too far from being done with the lesson today. So, the next research. And here we are. We're going to go down to key concept, factoring perfect square trinomials. Go ahead and pause this real quick and write it down. Okay, assuming you pause this, let's go. All right, and we're back. So let's take a look at this. Determine whether 100x squared plus 80x plus 64 is a perfect square. So let's look at this. I didn't really talk about it much, but you wrote it down. So we have a squared plus 2ab plus b squared. That's a perfect square trinomial, okay? And it breaks down into a plus b times a plus b, or if we have a minus there instead of a plus, it's a minus b times a minus b, which is a minus b squared, or before would be a plus b squared. Some examples are 4x squared minus 28x plus 49. Well, the square root of 4x squared is 2x, square root of 49 is 7. Since there's a minus there, we know this is 2x minus 7 times 2x minus 7, which is 2x minus 7 squared. Now, before we can break it down, though, and know for sure, we have to make sure the middle is equal to 2 times a times b, where our a is 2x, so 2 times 2x is 4x. 4x times 7 is 28x. Look at that. It matches. So because of that, it is a perfect square trinomial we can work. Same thing here. The square root of x squared is x. Square root of 25 is 5. So we have 5 times x, and then times 2 would be 10x, which is 2ab, matches the middle here, so it can be factored using this example. So this example right here tells me to determine whether or not this is a perfect square. Okay, so first of all, if it is, I have to be able to take the square root of these to start off with, which is going to be 10x and 8. That works, so we're on the good track so far. Now, if it is a perfect square trinomial, that middle term is equal to 2 times the 10x times the 8. 2 times 10x times 8, which would be what? 20x times 8. And what's 20x times 8? That is 160x. Those do not match. Therefore, it is not a perfect square. Okay, let's try the next one, the last one for the day before we get on the homework. Square root of y squared is y. Square root of 121 is 11. So 2 times y times 11 equals 22y, which matches. Therefore, yes. Therefore, yes. It is a perfect square. So now we know we can factor it into y plus 11, or it has a minus sign there, so it's actually going to be y minus 11 times y minus 11, which equals y minus 11 squared. Boom! With that said, peace out.